Alright, so this video is just reviewing the triangles quiz that you took recently. The goal here is for you to be able to watch this video and get some questions answered and make some corrections to your original quiz so that you can be ready to retake the quiz before the end of the semester. So let's jump into this. Question 1, are the triangles similar? How do you know? Well, in class, we discussed 3 different methods of proving that triangles are similar. The first method was the side-side-side similarity theorem. And what that said is that if you have 3 sets of corresponding sides that are proportional to each other, then we can say that the 2 triangles are similar to each other. So if I take 2 divided by 3, that should be the same as 4 divided by 5, which should be the same as 8 divided by 9. Or 2 over 3 is 4 over 5 equals 8 over 9. But 2 over 3 is 0.6 repeating, 4 over 5 is 0.8, and then 8 out of 9, 8 over 9 is 0.8 repeating. Those are not the same number. Therefore, these corresponding sides are not proportional to each other, which means that by the side-side-side similarity theorem, these triangles are not similar to each other. You do need to show me this work, tell me which method you used, and then answer the question. The answer would be no, because the 3 corresponding sides are not proportional. Now, there were 2 other methods that we talked about in class. One is the angle-angle similarity theorem. That only works if I have 2 pairs of corresponding angles that are congruent to each other. So looking at this, I only have 1 pair. However, if this over here was a 45 maybe, and this down here was also 45, then I could say that these 2 triangles have 2 pairs of congruent angles, meaning that by the angle-angle similarity theorem, I could say that the 2 triangles are similar. However, I only have the 1 angle. What I do have is I have an angle with the sides around it. So I have this angle is congruent to that angle. So our corresponding angles are congruent, step 1. The question then is, are the sides around it proportional to each other? Is 6 divided by 3 the same as 4 divided by 2? Well, yes it is. It's 2, which, by the way, is also our scale factor, going from the small one to the big one. The big one up here is twice as big as the small one. If we went the other way, we could also do 3 divided by 6, and see if that's the same as 2 divided by 4, and those both come out to be 1/2 or 0.5, which again would be our scale factor, meaning that the smaller one is half the size of the bigger one. So again, you would say, yes, these are similar by the side-angle-side theorem. I have 1 pair of congruent angles, and the sides around it are proportional to each other. That's a full, awesome, correct answer. Now, if we know that the triangles are similar, well, based off of the side-side-side similarity theorem, if they're similar to each other, then the 3 sides should all be proportional to each other, meaning that I should be able to set up ratios of corresponding sides that all come out to be an equal number. Meaning, if I wanted to find x, what I could do is I could say that x divided by 8 should be the same as 9 divided by 6. The key to this is making sure that you do, in fact, look at the corresponding sides. You can't just pick any side. It has to be the same side in relation to your triangle. So the next thing you would do is you would cross multiply, and you would get 6x equals 72. And then you would divide both sides by 6. It's just general equation solving, and you would get 12. X should equal 12. You can do the same thing to find y. You can do y divided by 6 equals 6 divided by 9, or knowing that this is 12, you could go y divided by 6 is the same as 8 divided by 12. Doesn't really matter. Now, when it comes to naming the similar triangles, since we know that they're similar, you have to remember that we list the vertices, the corners of our triangle, in the same order in both triangles. So A, B, C is similar to triangle QBOC. S, R. We start at a corresponding corner, and you go the same direction around the triangle for both of them. Now, number 3 is where things maybe got a little bit harder, just a little bit. And actually, 3A shouldn't be all that bad. It's basically the same as the last question. You're going to set up ratios of corresponding sides. So if you look, we have this purple triangle that's a little bit bigger and this blue triangle that's a little bit smaller. They both have a hypotenuse, they both have a longer side, and then they both have a shorter side. And if you look at it, the longer and shorter side of the purple one is given, or it's our variable. And for the blue triangle, we have the longer side and shorter side as well. So for this one, the way that we would set up our proportion is I'm going to do the ratio of the longer side of the purple triangle divided by the longer side of the blue triangle, which is x, equals, well, next I'm going to do the ratio of the shorter sides. The shorter side of the purple triangle is x, the shorter side of the blue triangle is 3. And then we would do the same cross multiply and get x squared equals 24. Don't forget how to solve these. Take a square root, so x is equal to, well, you can just leave it as the square root of 24 or simplify it or use a decimal approximation. This one down here is a little bit more complicated. We have this smaller purple triangle, and if you look at it, we've got the longer side and the hypotenuse of that. But then instead of looking at this other smaller triangle, you could do that, but you'd have to come up with some other variable. I don't want to do that. So instead of looking at this smaller one and this smaller one, I'm going to look at this purple triangle here, where I have the hypotenuse and the longer side, and I'm going to look at the big outer triangle, which is also similar to the purple triangle, where I have a known length for my hypotenuse, and x is my longer side. Hypotenuse, longer side. Hypotenuse, longer side. I'm going to set up my ratio of the hypotenuse of the big blue triangle divided by the hypotenuse of the smaller purple one equal to the longer side of the big blue triangle, which is x, over the longer side, what did I just say? Longer side, yeah, longer side of the small purple triangle, which is 18. And with this one, you're going to cross multiply, just like you did with the previous ones. Now over here is where we get into a little bit of trigonometry. I only have one side given in this triangle, and I actually only have one angle given other than the right angle. But you know what? If you can remember that this angle plus this angle plus this angle equals 180 degrees, because the angles of a triangle add up to 180, this is a fairly easy angle measure to find, because we would just take 180 and we would subtract 90 from that for the 90-degree angle, and we'd get 90. And then we'd take away the 30, and theta then is 60 degrees. Now to find x and y, I'm going to use trig ratios. I'm going to use my calculator. If you take a look, I've highlighted the angle and its adjacent side and hypotenuse all in this purple highlighter. Our trig shortcut, the thing for us to remember, is SOHCAHTOA, which, just to remind you, means sine is the ratio of the opposite side from our angle divided by the hypotenuse, or in this case it would be x divided by 10. Ka is cosine, is the adjacent side divided by the hypotenuse right here. And then TOA, well, that means that the tangent of my angle is equal to the adjacent side, TOA, T-O-A, it would be the opposite side divided by the adjacent side. And remember, the opposite side is always across the triangle. So if I want to figure out what x is, I have my angle, x is my opposite side, 10 is my hypotenuse. So I know I said I'd start with the purple highlighter, but let's go with the blue box. I've got an angle, opposite, hypotenuse. So setting up my ratio then, I've got sine of 30 equals x divided by 10. Now you just need to remember, good equation solving technique. We're trying to get the x by itself. So to undo the divided by 10, I'm going to multiply both sides by 10. And all I have to do is plug into my calculator 10 times the sine of 30. Make sure it's in degree mode. If it's in radian mode, you're going to get a weird answer. But it should just come out to 5.
Hi, can I borrow a ruler?
Yes. I think I have one in the basket right there. See the green basket on the shelf?
There's like 3 green baskets.
Yeah, it's the lighter green. Right, there you go.
Thank you.
You're welcome.
I will bring it back at the end of this period.
Awesome. Thank you so
And
much.
I will be in Miss McAvoy's room.
All right, sounds good. Sorry about that. I would have stopped the recording, but this was already the 3rd time I tried it and got interrupted. I'll try to cut this out, maybe. Anyway, where were we? Y. Yes, we're trying to solve for y. So looking at our triangle, adjacent side, hypotenuse, angle, cosine, adjacent over hypotenuse, cosine 30 is equal to y over 10, and we would solve that just like we did the last one. Now, part D down here, z is the 3rd side of this right triangle. You could use the Pythagorean theorem, or we could figure out what this angle is and then do trigonometry, but the best thing to do is just do the Pythagorean theorem. A squared plus b squared equals z squared. But to find the angle, what I need to do is I need to set up a trig ratio and then use the inverse trig function. So looking at the angle that I'm trying to find, I have the opposite side given and the adjacent side given to me. That's TOA, tangent, opposite over adjacent. So I'm going to say tangent of phi is equal to opposite over adjacent. Now, the tangent of an angle is equal to a ratio. So an angle, well, let me put it this way. So the inverse tangent of the ratio will give me the angle. And all you have to do is look for the inverse tangent on your calculator. You have to hit the second button, and it's the little blue words, I think, above the tangent button. It says tan, but it means tangent. All right, I hope that's helpful. Let me know if you have any questions as you prepare to retake this test.